Welcome, everyone. Thank you very much for joining us today. Today, within the scope of VBenzeri Campus events, in fact, there will be an event that excites all of us very much. As you know, building information modeling is becoming more and more important day by day. So today we have a webinar on that. I would like to really extend my sincere thanks to Binat Yayıncılık, especially Ayşegül Tuğtepe and Neslihan İmamoğlu for the organization of this event, and also our contributors Dursun Furkan Çapkın and Veysel Açıkel. And I am leaving the word to Neslihan Hanım for introduction. Thank you very much.
Thank you. Hi, everyone. You're all welcome. I'm from Binat Communication and Consultancy, and I coordinate this project with my colleague Ayşegül Tuğtepe. This project is for students, and it's created by VitrA and Binat Communication and Consultancy. And as Binat, we are a creator, consultant, and coordinator of this project. First of all, we would like to thank all the university, and specifically these names: Nilay Ünsal Gülmez, Mine Dinçer, Sezin Hatice Tanrıömer, Melek Emir Somer, Sinan Kültür, Bengisu İksoy, Zeynep Gül Sohman Tünay. Thank you. Since 2017, we have visited more than 30 universities, and we met more than 7,000 students. Actually, all these universities, we have the same topic, BIM. Actually, this project, VBenzeri Campus, is a project for not only students. It's also for contribute the formal education, actually, because some topics are we rarely see them in universities, and now we can start to see BIM, actually. But when we started this project, all these professors and students mentioned that they have this problem. They can't reach information about this subject. So we started this topic while we started this VBenzeri Campus project. We choose this topic as first starting. And since March 2020, due to pandemic, all we know, we started to make our events online. This one is our 25th digital event, actually. Today we have two contributors, as you can see, Dursun Furkan Çapkın and Veysel Açıkel. Also today, Buğrahan Şirin from HPP International is going to with us, and they are going to make a presentation with Veysel Açıkel. So we may start with this, with first presentation, Dursun Furkan Çapkın, and his title, BIM and Information Management. So I can leave the screen. Thank you.
Thank you so much, Ms. Neslihan. I would like to thank the Binat and Bahçeşehir Üniversitesi for their kind invitation. Today, I will make an introduction to BIM and information management. My presentation will be a little bit different. First, I will talk about the theoretical part. After that, I will show you how you can do it, how hands-on application is working. You will see. If you will have any question, please do not hesitate to ask. let's start with what's BIM. We are living in the 21st century, and this century is calling as information age. There is a huge amount of... Is there any question? Okay. There is huge amount of data. We are trying to get meaningful data from there. This thing is calling as big data. It's a computer jargon, but we are using in architecture. Our main object is to create new paradigms. We have existing paradigms, we have existing patterns, and we are creating new patterns. We are combining them. Because of this reason, we have huge amount of data to get a meaningful result. Because of this reason, we have to manage this process as well as the best way we can do. In this age, architect's role completely changed because today's architect have to manage too many information, too many disciplines. We have many tools to enable this process, but you have to follow the regulations to reach the correct position. Because of this reason, architect's role changed. Today's architect is the chef of the orchestra. We can call him or her as orchestrator, information orchestrator. Let's look at Le Corbusier's picture. On this picture, Le Corbusier talking with construction company's owner, contractor, and he's saying, I love my drawings and I don't care if you can do them or not. Let's remember, who is the Le Corbusier? Le Corbusier is the avant-garde architect. He is the frontier of his age. He found many different types of the buildings. He changed the application of the architecture. At that age, contractor never built up a building like that. So contractor said like, response like that, how in the world did he think I could build that? There was a huge gap between design and construction. Because of this reason, we need BIM process and management. And this picture didn't change since 1960s. Same thing happening even today. There is designer and contractor, and there's a huge gap between them. So how we can solve this problem? At the old times, we were working on our silos. Let's look at what's the silo. I think everybody went to Kadıköy at least one time with ferry, am I right? When you are passing through, did you see these silos? These are calling as agricultural silos. Tarım Mahsulleri Ofisi in Turkish. It is the same thing. We were working on our silos. What is the main aim of these silos? There can be many grains, corns, and other kind of stuff. The main aim, all of them shouldn't touch each other. All of them must be in their place. This place for corn, this place for grain. This same in our working style. Architect, engineer, landscape architect, interior architect, construction engineer, all of them working on their places. Today's working style completely changed. Because of this reason, we are using a common data, common environment to work on it. How we are working? Modelers, architects, engineers, and other disciplines working on the same area, and everyone can reach that area to manage or get a meaningful data from there. I would like to talk about an example. I would like to talk about the Zaha Hadid Architecture Office. In this office, they have 427 architects. But today's architecture world, it completely changed. How we can understand? They have subdivisions. 427 architects, they divided up to some partitions. One partition is research group. What they are doing? They are researching and trying to find meaningful new data to use in their projects. The other group, all of them architects, please don't forget, architects divided up to the subcategories, subgroups, subdisciplines. Another group just coding. They are just coding to enable their project more easily, build up them more easily. Material technology, they are trying to find new type of materials. Another group is BIM group, BIM group. This group modeling the designs. Another group, sustainability. They are making sustainability analysis and other kind of stuff. So we have BIM, we have subdisciplines, and we have many problems. These problems from a survey. Every year I am making at least 4 surveys. One of them sector professionals, the other one to do university students. These are mixed problems. What kind of problems they have? They design something and there is a problem when they want to applicate it on the construction site. They describe what kind of problems they have. Some problems with the process, some problems with the colleagues, some problems with the system. There are many problems which we have to handle. Okay, we try to describe, we try to draw a picture, but what is really BIM? BIM is like elephant in the dark. Indians has got an epic story. On this story, one ruler sent an elephant to a village to show villagers elephant. First, they put the elephant into a dark barn. After that, they take the people, villagers, inside of the barn one by one. The first villager held the ear of the elephant and he said, elephant is like hand fan. The second one held the nose of the elephant and that person said, elephant like a gutter. The third one held the leg of the foot of the elephant and said, elephant is like a phone or column. The last one climbed on top of the elephant and sit on there and said, elephant like a throne. This is the exactly correct situation in this world. Everyone holding a piece of BIM and saying, BIM is this one or that one. BIM is all of them. BIM is not just a part, BIM is all of them. Okay, let's talk about what is BIM. BIM consists of 3 stages. One stage is human, second stage is technology, the third stage is process. Under these stages, we have subcategories. These 3 things, triple trivets consist, triple trivets creating the BIM. All of them must be in your project. If you don't have one trivet, there is a problem for you. Okay, under the human, what kind of things we have to create? What kind of things we have to develop? First of all, cooperation and communication. How they will cooperate, how they will work collaboratively. You have to describe and you have to give informations, lectures about these kind of things. The other one, communication. Communication is the biggest problem of our age. What is the problematic side of the communication? Generally, I think you are using Gmail or WhatsApp. Am I right? What you are using, Gmail or WhatsApp? Or any mail address you are using? Okay, I will continue. Generally, people using these kind of systems, but today's world, we are using dashboard programs. I would like to show you one dashboard program. All students asking me many questions, and look at the time. Now, 14 minutes ago, they asked one question, and every kind of answers in this dashboard. For example, they have a problem. They will just write down the problem here. After that, they will find a solution to that problem. displays a kind of collective memory for us. When you need an answer, you will just check displays or you will ask. And there is a nice thing, many students replying to questions. I don't have to reply because my students sometimes they leave that problem. They are just answering the problem. This process, same in the professional study, professional work. It's the same. There is no difference. All of them using this kind of system, and I can show you. Now, I didn't assign any professional company. I hope next time I can show you. The first one is this one, how they will communicate and how they will work together collaboratively. You have to develop techniques, you have to follow the regulation. The other one, knowledge and experience. Knowledge, you have to teach how they will use BIM, how they will use tools, processes, how they will communicate, how they will cooperate. You have to create their knowledge. You have to put knowledge on top of each other. After that, they will have experience. If you do not teach anything, they can't have experience and they can't do anything. The other one, trust and commitment. This one is very important on a company. Why it's important? I was working on one company. Sometimes I am leaving education and attending to the companies to get the latest data, the latest techniques from there. I was working on one company. At that company, there was a CEO. That CEO, there was a project consists of 6 buildings, which each one of them has 30 stories. He gave 3 buildings to my team, 3 buildings to architectural team. My team consists of 1 architect, 1 mechanical engineer, 1 mechanical technician, 1 electrical engineer. With me, 5 persons. Architecture team consists of 16 architects and 2 managers, total 18 persons. We finished the project, BOQ of the project, in 2 weeks, and we changed 5 times. They finished in 1 month, and they made a mistake, 18,000 square meters. It's a huge and dangerous mistake. I went to CEO and told the CEO, I trust my team, and we did the best. It's the correct one. And he told me, I trust you. Now he trusts me, and I attached to him. This one is very important in a company. After that, we checked. Architectural team did a mistake. Because of this reason, our solution was the correct one. 6 months later, CEO changed. There was a new CEO, similar project. Again, 3 buildings to us, 3 buildings to architecture team. This time there was 8,000 square meter difference. Again, I trust my team and said to the CEO, CEO told me you did the wrong thing, turn back to CAT. CEO didn't trust me. I didn't attach to CEO. After that, I quit the job. This one is very important in a company. You have to create trust and commitment, attachment. The other one, duties and responsibilities. All of the participants, employers, construction site workers, modelers, everyone have to know the duties and responsibilities. All of them described before the project started. When we look at the technology phase, on this phase, we have data security and user management. Again, I have a problem. When I was working on that company, one of my colleagues quit the job. When she quit the job, she locked down everything. She put password to everything, every folder. Because of this reason, data security and user management is very important, and we are using Windows protocols to reach folders, files, who will read, who will write, who will read and write. We have different protocols, and you have to know these protocols to do a better BIM model. The other one, hardware and software. Generally, everyone is saying Revit is not BIM. Do you know why Revit is not BIM? Because under the technology phase, we have hardware and software. Under the software, we have 10,000 programs. One of them is Revit. Because of this reason, Revit is not BIM. BIM is a process. We have to get a meaningful data. When we look at the hardware, hardware is important. I would like to give you an example. When you are collaborate with team members, let's think my computer speed 10. Other person computer speed is 50, the other one 70, the other one 100. When we are collaborating, when we are preparing a project together, all of them speed decrease to my speed 10, 100 speed decrease to the 10. Because of this reason, hardware is very important. Software is important. Data formats and structures, what kind of data you will use. Before you started a BIM project, we are limiting the data formats and structures. I would like to give you an example. There are main file formats. What are they? RVT, Revit file format, PDF. These are the main file formats. And we have secondary file formats, CAD, DWG, and WD, Navisworks file format, CLAD data format, and some other formats. There have to be limitation. Do you know why? We have software header. Under the software, we have 10,000 formats. If you do not limit these data formats, versions, and structures, everyone will use a program however they wish. And the other one, the last one, talents. We have to increase the talents of the people about technology. Many people don't know how to use new technologies. For example, now we have many colleagues here. Colleagues now, they know better than us. Maybe there are older colleagues than me. They know better architecture perspective. They know better construction. They know everything. They just know the technological process and programs. Because of this reason, we had to develop these talents. The last one is the process. Process consists of application and maintenance. How you will create a project, how you will maintain that project, how you will maintain a hardware or a software. This is very important. When we talk about the maintenance, everyone thinking something physical. We are not talking about something physical. We are talking about a digital asset. How we will maintenance. When you will take care of the file, when you will do what? All of them describe in the some standards. We will see some standards. They describe how you will maintain your file, how you will maintain your hardware, everything described. And some companies creating their application guides. When you read them, you will understand how you can create, for example, a family, how you can create a project, all of them described in there. The other one is design and coordination, how you can design and coordinate a project in that company or in your university. The one cost estimation and quantity, we can call it as BOQ. Another one is timing and process management. This is the fourth and fifth dimension. The last one is change management. In this company, how you will change the total system. It's about it. What is the biggest problem in this world? Today, architectural world, the biggest problem, we are understanding BIM as a tool. If you understand BIM as a tool, it means you are doing little BIM. You are just using a BIM program, such as Revit, Bentley, Archicad, Vectorworks, and other programs. If you are using that program, it means you are making little BIM. This is the biggest problem in this AEC sector. Okay, what we are aiming, what we have to do big BIM, management of the knowledge, information, and complex relationship between social and technical resources from the beginning of the project until to the end. What's the end? Renovation or deconstruction. On each phase, you have to use BIM, tools, and processes. What kind of dimensions we have? As you know, we have third dimension. The fourth dimension is scheduling, timing. The fifth dimension is estimating, BOQ. The 6th dimension, sustainability, energy analysis. The 7th dimension is facility management. Okay, on each phase, what kind of phases we have? You can see we have programming, concept, design. I think you can see the circles. Programming. At this stage, everything on the thinking stage. Programming stage, concept stage, concept design stage, detailed design, analysis, documentation, fabrication, 4th and 5th dimension, construction logistic, maintenance, renovation, and deconstruction. On all of these phases, we are using BIM. But why it's like brain? On each phase, we have to think. What's my purpose? What I will do? How I will do? I will work with whom? What's the whole process? Because of this reason, we have predefined technical standards. One standard is describing how we will work and how we will share the information. This one is calling as common data environment. You can check the ISO 19650, ISO 19650. This is the latest standard now in use. That standard is describing a working style, work in progress, shared, publish, and archive. How we are working? When we are working on the project, every information in work in progress. I would like to show the folder structure now. This is the folder structure. When I enter, I am working on VIP because this project is continuing. I enter the VIP. My discipline is architecture. I am making BIM models. This is that easy. It's very easy to find the information and everybody knows the location of the files. The other one, we changed the working style. How we are working today's world? We are collaborating. I was talking about the silos. Now we completely destroy the silos. Now everyone working on the same file, on the local area network or wide area network, cloud servers. A few minutes later, I will show you. But before I started that folder structure, I would like to talk about a subject. Today's architecture completely changed. Did you remember? I talked about the Zaha Hadid office. Now, this is one academic paper. On this paper, they just search for the BIM jobs. Today's world, we have many BIM jobs. All of them architect or engineers, by what they describe as a different architect. They want some specific talents today's world. You have to design, you have to code, you have to energy analysis, you have to understand the material technologies. Even Turkey, now I am in a group in architecture, Chamber of the Architecture. We are talking about, is there BIM architect, BIM engineer, or just architect? Now we are talking about this subject. And it's changing so quickly. Okay, how we were working? I mentioned about silos. One architect working on his or her computer and preparing a file. Engineer working on his or her computer, preparing another file. Interior architect doing the same. They are sending with USB or mail, or they are sending on WhatsApp or something else. Am I right? Everyone using this technique. Is it correct? Okay, there is no response. I will not ask any question. The other technique is LAN. LAN means local area network. On this technique, you have a server in your building and you know the place of the server. It means you can touch the server. This one is calling as LAN, local area network. There is a central model here. That central model, everyone on this project, they are reaching the central model and creating a local copy. When they make any different thing on their project, it is directly appearing on the central model and other team members can see it. But don't forget, this is in your company. The other technique is WAN. It's wide area network. There is a server, you don't know where it is. It can be anywhere in this world. Is there any question?
They say that I think some of the students has written that they can't use the microphone. That's why you are not maybe hearing their voices.
Okay, thank you guys. You can write down your questions if you want to respond, okay? You can write your questions to the chat. No, it's not reliable. Do you know why? One is the best one. We can call it as cloud server or one. Now let's connect to one server. Would you like to see? Now I would like to connect to my one server. I think I have 20 minutes, am I right? First, I am connecting to one server. This server is where it is, I don't know really. Somewhere around the world. I don't know where it is. I connect to server. When I connect to server, it is acting like a part of my computer. Now I enter to Revit and I would like to open one collaborated project. Now my students all around the world, some of them from Germany, some of them from Syria, some of them from America, even in different places, different states in Turkey. Manisa, Bursa, Hatay, Izmir, Ankara, many students connecting to this area. What is this area? Now you are seeing 150 different projects, 49 different projects. And all of them consist of 2 or 5 persons. When I want to connect to one project, I will just enter. Look, this is the common data environment. Everyone knows where to put the information. Look, there is a project. When I click on top of it, I can directly connect to my project. These are the local projects. They are not for collaboration. Let's find one collaboration project. Okay. This one is central file. When I click on top of it, it is saying you can create a local copy of it. When I click on top of it, I will connect to that project all around the world. For example, I am on top of the Trabzon's mountains, okay? And there is internet connection. I will just open my laptop and connect to my project. I can change whatever I want. You cannot do it on LAN. It has to be cloud server or one. I think it will take a little bit time. When I make any different thing, my colleagues, my team members will directly see in seconds. Let's continue. We can check it later. The best one is one, okay? When you're working on a company or when you are working on your university, you will use LAN. In a real company, I think you will use one. Let's continue. What kind of documentations we have to use to be successful? No need to buy a server. You can rent a server, but there are many technical requirements you have to know. I will talk about them a little bit. What kind of documentations or what kind of things we have to know for a successful BIM project? Many standards you have to know. And I talk about 3 stages. You have to know these 3 stages. BIM using standards. In a company, there is a booklet or there is a book which is describing how they are using BIM in that company. project folder structure, what kind of projects they have, and where you will put, when you will put, and how you will put. BIM uses. Before we start a project, we are describing the BIM uses. I would like to give you an example. For example, let's think about a BOQ project. On that project, we just have to count the things. For example, tables. I have one table. I can model that table. If I will just count it, I can model that table just a little box. To create this box, it will be 2 seconds, okay? But when you are creating application project, you need many information. To create that table, let's say it will take 1 week. Before we start a BIM project, we are describing our purposes, why we are using BIM. If you will just count, it will 2 seconds. If you want application project, it will take 1 week for one family. I would like to show you one example. Let's turn back to Revit. And this is a collaboration project. When I click on top of it, you will see, look, I open the construction site, I think. If I change anything, my students will directly see it in a second. This is the site. They model it on the Revit. And these are the site buildings. I think it will take time. Okay. I will wait a few seconds more. After that, I will turn back to presentation. Okay, let's turn back to presentation. We can turn back later. Okay, we need technical documentation for a successful BIM project. What kind of things written inside of these technical documentations? In my presentation, everything you saw, it's a part of my PhD. Because of this reason, you can't find these informations on the internet. You can find the technical standard and other things on the internet, but these booklets you can't find. All of them belongs to me. I described everything. When you started to work on a company, you will see everything they described. For a successful project, what kind of informations we need? First of all, customer coming to us and asking for a project. Let's call it as perinatology hospital. Customer told to us, I want 100 beds. I want 3 surgery rooms for newborns. When they labor, we have to create predefined areas. This one is calling as project development needs. The other one, model development needs. For a successful model, we have to describe the element level of detail and information level of detail. What is element level of detail? It is describing the 2D and 3D shape of the model. What is information level of detail? Which information, when you will add? First, customer's needs. What's the customer need? Hospital. What will be the project, hospital project? What kind of models I will see? What kind of information I will see? I describe everything before I started the project. And I think we have, okay, we have this one here. Let's see it. This one is calling as LOD tables, element level of detail. When we look at here, architecture, engineering, mechanical, and electrical disciplines. When I look at the architecture discipline, ceiling is architectural asset. When I check the first phase, design development phase, I am not modeling. When I will model it when it's application project. And what is the detail level of detail? Load 200. The 2D shape will be lot 200. The 3D shape will be lot 300. And you can ask, what is lot 200? What is lot 300? You can check the BIM forums lot tables, and I would like to show some information. Lot 100, you will just see the general shape. Lot 200, you will see a detailed model. When we come to the lot 500, we will model even the screws or RG45 units. You will model everything on lot 500. And what was the difference? For example, this one, 2 seconds, this one, 1 week. There's a huge difference between them when you are creating these kind of informations. Because of this reason, this table is very important. And the other one was the ILOT, information level of detail. For example, you create a door and you assign a parameter which is fireproofed. This parameter has specific values. One of them, is it existing or not, true or false? Then I will add this information, lot 300, lot 350, lot 400. Before, I don't need this parameter, so I will not put these technical specifications to my door or anything else. Everything described on this process. What kind of standards we have? We have many standards, and please don't be afraid. Do you know why? I didn't read all of them. I know what's written, all of them, but I didn't read them. There are main ones, main standards, I just read them. Other ones, when you need some technical informations, you are turning back to these standards and checking them. This is the histogram of the standards. They started from 90s. At 2020, I think, they released the ISO 19650. It's the latest standard we are using. You should read it. It's one of the best standard now. This is the histogram of the BIM programs. The first program, I think it was 1967 engineering program. I forgot the name of the program. And we have many, many programs you can use. Some of them today existing, some of them missing. They completely demolished the programs. There are many programs in BIM process which we are using, and we have some aims. Why we are using? We have purposes, we have characteristic specifications. For example, you can use BIM to collect the information or produce a building or just for checking clash detection or constructing up something. This purpose is very important because it is gaining time and increasing the productivity of the team. We have many described BIM uses in Turkey and all around the world. For example, you want to construct a harbor. When you check the Harbor Authority of USA, at least they describe the 50 BIM uses. There are many BIM uses you can find on the internet. This is one thesis, master thesis from Mimarlık University. Okay, what kind of studies they did? I would like to show you some studies. After that, I will finish the presentation. These are the student works. On our projects, what are students they are doing? First of all, they are finding which place will have high temperature, which place will have low temperature. It means where you have to heat, where you have to cool down. All of them they are finding. After that, they are changing their design according to these analyses. Other one, they are modeling the wind. When they put a window, they are simulating, is it on the correct place? Is there a stack effect or is there a vortex? They are modeling. After that, they are designing the correct place of the windows or any doors. When we look at the site plans, when they are constructing their site, they can understand the levels, they can understand the whole site very easily and what kind of specifications they have. They can simulate the view analysis or any other analysis. All of them now student projects. They are producing these projects with Revit and other BIM tools. And these models has the level of lot 500. Even the little screws they modeled. And they gave us BOQ of these projects, what kind of things they did. Sun analysis, shadow analysis, some additional layer analysis, wind analysis. They did many analyses to get the best solution. Sometimes they use generative design, orientation, or facade. They use these kind of things for their best result. This is the structure of their model. They completely model lightweight steel structure with BIM process. Did you remember what was the biggest problem? Biggest problem was the gap between design and construction. Before they construct the building, they are designing and constructing on the BIM process. Because of this reason, they are finding every problems, and before they build up the building, they are fixing all problems. I would like to show you some interior examples. All around the world, I think less than 5 or 10, maximum 10 universities, they are giving a lecture like this one. What is the important part of this one? They are modeling everything, even the smallest line they are modeling. What's the aim of this modeling process? When they model, they can send these models to the 3D printers or fifth action drills. All of them can produce these models. I would like to give you an example. When I was working on Qatar, I was working on Qatar Metro project. We were modeling very detailed octagonal shapes, wall shapes. When we modeled them, we were sending them to the fifth action drill, and they were directly producing it, giving it back to us. Is it correct or not? We were trying model to construction. It was just half hour. These models you can send to the 3D model, 3D printers and fifth action drills. You can send them, they can produce these models, and they are very detailed. And we are using a different technique now. I think I can show. I hope my Revit is working. Okay, let's close. I would like to show you one example. I talk about the different levels of the project. Am I right? This is the plan. This is the 3D. Now I have 6 levels in this family. What kind of levels? First of all, I will ask the project, what's your size? Lot 200. Now my table is lot 200. I will ask, what is lot 200? This is the lot 200. How much space it has? The second one, what is the general shape of it? Let's call it lot 300. This is the lot 300. I click here. This is the lot 300 now. Again, I click lot 500. I would like to see the latest shape, the maximum information. Now it's lot 500. You can put different level of information to your model. With one element, you can finish everything. I think my last 5 minutes, am I correct? These are the examples. And you can ask how you can build our information. On this example, there is an architect who is 48 years old. He took lectures from me, I think more than 300 hours he took. After that, he was building up the project very easily by himself. But when we came to the collaboration subject, there are 16 architects. They couldn't finish one floor of the building. They couldn't finish in a one day. more than 8 days it took. They don't know how to collaborate. They know architecture and other processes very well, but they don't know how to collaborate. They don't know how to build up their information. Because of this reason, we have to change the education system in the universities and in companies. This is the new method of working. They have to build up the information first. How they can build up? They learn. When they learn the dividing information to the pieces and representing on the BIM process, they finish the whole building in 6 hours. Only 6 hours. They finish the whole building, 30-story building, they finish it. When they learn how to build the information. What kind of things we can do on this process? Purpose of the modeling, naming conventions, material specifications, technique of the modeling, task sharing, and segmentation of the model. They have to learn. When they learn, they are executing the process very easily. I would like to finish my presentation with the sentence of the Alvin Toffler. The illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. Thank you so much for listening to me.
Thank you very much. I think that was a great lecture. Since students cannot speak, I mean, you don't hear them. I just wanted to, tell my feelings. Thank you very much.
Thank you so much.
Thank you very much, Furkan. Maybe it's the problem is about the webinar format. Maybe if we make this presentation another format with students, maybe we may see their faces and hear them. It would be better. Maybe we may try this kind of events. And now, Veysel, we are listening to you.
Oh, okay. Can you hear me?
Yes.
Okay. First of all, thank you very much, Professor Çapkın. It was really comprehensive, detailed presentation. Let's see what I can deliver. Is my screen shared now?
Yes, we see it.
Okay. I'm Veysel Açıkel. We were planning to do this presentation with our office director, Buğrahan Şirin, but he is busy with ChatBIC board meeting. He may join us maybe at the end of the presentation, but I can give him some credit. They are trying to save the world with sustainability and green buildings. I'll do the presentation by my own. And first of all, I would like to talk about the office that I am working for. I'm working for HPP Architecture, which was founded in 1933 in Düsseldorf, Germany. And HPP provides architectural services with the 5th generation of the directors. Together, more than 400 architects all around the world, in total in 13 offices. And one of the offices is in Istanbul, and that's where I'm working. And in the office, my responsibilities and focuses on the various projects are mostly about designing and modeling and documentation. And today I will talk about the relation of architecture and computer-aided design, not from the futuristic perspective, but more about notional base. And I will try to establish an approach to BIM or parametric design or any kind of modeling approaches in computers. And I will start from an abstract point of view, and I will try to solidify those ideas with down-to-earth, more kind of practical projects. As mentioned before, as we are modeling an item, which can be a point or a line or a surface or a 3D object, we associate those items with text information and identify them as architectural elements. Like a cube can be a beam or a wall or a column. We are defining what it is with text information. As the process of the project goes, for different phases of the project, we use different level of information, as it is mentioned before, which is considered as LOD, level of development. That was a great example with that simple table. Like as we have one written and one drawn as geometrical element, information for each architectural elements, we can reduce all kind of information down to two types. One is text, the other one is integer, numbers, I mean. The texts are semantic to us. We can get meaning from the text, but we cannot get any semantic from the numbers, because numbers are not semantic. Even the computer is not semantic. But today, I will mainly focus on the integers, on the numbers, from geometrical point of view. And let me be more provocative on that way and start with asking if those two, not necessarily cube, but boxes are identical or equal to each other. Let's even think that their all dimensions with height, depth are same, and they are even in the same location in this space, in the outer space. Can we still say that they are identical, they are equal or not? This is an interesting question. Well, by the appearances, we can say, yes, they are identical, but as we are investigating on this topic, we might differentiate some qualities, quantities about it. And this question directs me back to Ludwig Wittgenstein, an Austrian philosopher. His book is called Tractatus Logicus Philosophicus. And in that book, he has many kind of entries. He is describing about many, the book is about the language actually, but he has so many different ideas about the objects, about the designs, about the images. Some of them are, I will cherry pick some of them and read here. I cannot memorize them by heart, sorry. For example, this one, he says, if I know an object, then I also know all the possibilities of its occurrence in atomic facts. Every such possibility must lie in the nature of the object. Any possibility cannot be subsequently be found. So what he says, like, to knowing an object is knowing all the possibilities, upcoming possibilities for this object. And in the next entry, he says, in order to know an object, I must know not its external, but all its internal qualities. So what he means here by external and internal, internal means is how the object it's occurring, how it's being, but an external one is how we are observing the object. So from now on, I will call it external qualities as properties, internal one as attributes. Like what makes the object is the attributes. How we observe the object is the properties. And in the next one, he says, if all the objects are given, then thereby are all the possible atomic effects are also given. So we should think of that. Let's put it down to earth by an example of, let's say, a door. Okay, what's the idea of door, and what is an actual door that we are opening and entering a room? Is there a door up above somewhere as a concept, and as we are making a door, we are inheriting all the information from that and creating this one? Or a concept of the door is the sum of all possible doors? I think the second one is more convenient for me, because as we are creating a concept, we should include every kind of possible doors into that one. Because to creating an abstract door up somewhere above in the space may require to reduce all the possibilities, all the informations actually. And I will jump to this one. The possibility of its occurrence in atomic facts is the form of the object. So as we combine all different kind of information together, creating a relation with different informations, the object comes actual. So this is more conceptual. Let's make it down to geometrical purpose. As we all know, 2,500 years ago, Euclid written a book which is called Elements. It's resembling with the Tractatus, or Tractatus resembling to that one. He's starting with the definition of the geometrical elements. And the first definition is that he says, a point is that which has no part. Definition number 2 is a line is breadthless length. It's not widens, it's just stretches in the direction. And in the definition 5, he says a surface is that which has length and breadth only. And the definition, in the definition 15, he says a circle, well, I'll summarize it. A circle has a point, and from that point, as you draw a line, all the circles, all the lines are equal to each other by length. And this point is called center of the circle. And after about 2,000 years, in 1600, a thinker from Netherlands called Spinoza disagrees with those ideas. He says those definitions are nominal definitions. They are called as properties. As we observe the object, we are taking this information from it, but these are not the attributes of the object. This is not the way the object is created. And what he suggests is, let's think of a sphere. He says, take a circle, and alongside of one of the diameter, as you rotate the circle, the sphere occurs, is being of the sphere. Okay, we got the sphere, we should get a circle actually. He says, take a line, one point is stable, the other one is in motion around it. As it turns, as long as it turns, there is this circle. So there's a motion again, one static, one positive movement. Okay, we got the circle, but we need a line. How to create a line? He says, take a point alongside any vector. As you translate the point in that direction, you will get a line. But there is also another modus he's creating to create a line. Okay, we got the line. We need to define the point then. And here he says the point is a causa sui. which means the reason for itself. And he describes in another chapter saying that in all the moduses, all the way of creating geometries, it was a part with static and with movable. And the point is happening, the movement and stoppage happening at the same time. Well, we don't have to agree with the way Spinoza thinks, but he's creating a way for us to think, a way to create an object, not with the properties, but with the attributes, with the relations, with the modus. And let's think back to those two boxes. Let's think that the box on the left side is created or defined by the motion of the lines. So as we taking one point and dragging it to the right side, and then taking this one, dragging it, leaning inside and extruding it up. So this is the way to create of this box. So let's think about the other box as a central box, like we are taking a point and extruding it in 3 dimensions, and we're creating a central box. So as the attribute definitions and relations are different for these 2 boxes, we can say those even the properties, even the dimensions are same at some point in some part of the space. We cannot say that those 2 boxes are identical. I will give a little bit more example about different way of doing different geometries. One of them are called chaos games. You can find many examples on the internet, on the Wikipedia. One of my favorite one is this one. It says, this is XY plane. Just take 3 non-random points and let's initiate one more random point anywhere. It could be even as 3 dots will create a triangle. The point could be even here. It doesn't matter. I put it here. And the rule is that from that start point, select randomly one of those 3 dots and go halfway through. For example, we selected point A. From point 0, we go to point A, and that will be the point 1. And we repeat again. Select one of those 3 dots and go halfway through. Let's say we came up here, and then here, and then here, and then here. So it makes no sense, like as I'm drawing it by hand, but we can make computer make this happen faster than human. And it might be down to the coding by Python. And as I implemented it in Grasshopper, in Rhino, that shape occurs. So we know this shape as Sierpinski triangle. It's a fractal shape. But the thing is, if we would like to draw a Sierpinski triangle, we would draw it by hand and finish it that way. And at the end of the work, we could get only one Sierpinski triangle. What Chaos Games claims that in this rule, every possible Sierpinski triangles are hidden. As we change randomness, as we change initial points, we can get so many different kinds of shapes. I'll give you one more example. This is by Barnsley, English mathematician. He's writing down this formula, which might seem intimidating at the beginning, but we can tear it down to the functions. And he is defining 4 different functions with different probability weights. For example, this function will run at 1% of the possibility, this one 85%, this one 7%, and this one 7%, sums up to 1. And it's giving different fractions to different numbers, and X stands for X coordinate of a point, Y stands for the Y coordinate of a point, and think of a XY plane again. And we can write that down to code in Python. As we implement this on Rhino Grasshopper again, that shape occurs. It's a fern. So what Barnsley claims here, that if you are up to modeling a fern, you will end up with one fern. But if you run this code with different variations of numbers, you will get a forest of fern, and you don't have to think of which one is better or not good looking. You can even cherry pick whatever you like. Imagine you are designing a computer game, just like post-apocalyptic world, like Last of Us, and you want to create a vegetation around. So with this way of thinking, you can make it more natural. Okay, that was a little bit maybe too fast or too slow. Please warn me if anything is off the road. But I will, from this perspective, I will talk about a project which is Central Bank project, a competition winner in Istanbul Finance Center. As you can see, it's pretty high, 54 floors. And the initial requirements for the design was that we were given a shape and we were free to design anything we want in that shape. And in the design, we split the tower to the 4 parts. I mean, not exactly a split, but a setback in the middle, and little bit more variations on the podium size, which is 7 floor height, and a more welcoming opening. And the tower, as it goes up, it's leaning to the sides. And after a certain amount of height, it's the gap front facade is leaning back, and some references to the side. And then at the top of the roof, we are pushing it inward and finishing the shape. And that happens. Design idea was to not to make it more scattered shape actually. And we have mullions. Some of the corner ones are from top to the down. Some of them are ending here as those fuga is widening up. And all those mullions are meeting up somewhere above. And we had this shape above the building. And with TCMB wanted to change the shape to the Selçuk star, which was not a bad idea, I think. And that was the latest design. But the thing is, as our building is tower is not super symmetrical, which is 49.2 meters to 50 meters. But Selçuk star is a supersymmetrical shape. So as we stretch it, we could lose some angles here, or here, or here, and we could not keep those lines parallel to each other, and we cannot relate all the mullions, smoothly connected to each other. Yeah, here you can see the facade is going up and then leaning back, leaning sideways, and there are also additional mullions coming like this. This is the core, this is the shell. As they wanted that, after that they said, okay, maybe we can make the building 50 by 50 or 49.5 by 49.5, like super symmetrical. And then we said, okay, if they are changing it now, they may change in the future. And what that makes is making as this fuga is going inward, is changing the slab shape on every floor and to the sideways also. And we may need to create new floor plans as they want a revision. So it's a lot of work actually. So we said, okay, let's define this fuga behavior with the functions, with pure mathematical functions. As the fuga is like this on the 11th floor, it will, as it goes up, it will go that way or backwards, or this point will go to here. Actually, it has two motions going backwards and side, to left or right. And this is the central axis. So here is the function. It's, what is it? Is it I am is the initial motion? Well, I have to tell one more thing before that. Our grids are 135, which is the German standard to make proper windows and proper interior usage. But for 49.5 or 50 is not divisible with 135 grids. So we can use the retainers in the middle. So, and we are flexible because we don't know what this gap width is. So this is not fixed, but here we fixed it with 255, 255. And as this point is going to left with FF function, for the FF is here we can see initial height divided by floor height and with iteration. So it is like, and here we are ending up, as I remember, yeah, at the end, we are reaching up 442 centimeters. As we, for FP, it starts from here, going here, and then ending up here, and this is 442. For example, this one is, as we add up these two, 495, yeah, here, 495. So as they would like to change the shape, we can implement new points to here and then a shape occurs. So we made a mass model in the Revit. We put all the relations down to here with the new numbers. And as we slice the shape from every given floor height, we can get the slabs. So from up to here, it's all different. And then we can implement our facade system. But the point is, as this fuga reaching up, it's also defining the Selçuk star at the top. And we want this Selçuk star to be perfectly shaped. As we are optimizing the numbers, we are getting different numbers. And we bargained, and they agreed that has to be 45 degree. We are agreed on 44.84 degree, which was reasonable actually. And yeah, that was the latest shape. And we could even play with the grid sizes of the facade mullions. It could be 135, 136, which is consulted with the facade consultant. We could create different variations of it. And after that, as we created what they wanted, we start to play with the code. So what I'm claiming here, as Barnsley claimed, in this fuga algorithm or the formula, whatever we call it, all the possible revisions are hidden, and we can create as many as we want by playing the numbers. Okay, let's get a little bit more down to earth. I'll talk about an ongoing project on the construction site. How am I with time-wise? I'm doing good, okay. This is a project in Frankfurt in Germany, designed by UN Studio, and construction drawings are going on right now. I'll briefly talk about the project, which contains 4 towers, and the name of the project is Frankfurt 4, we call it F4, coming from those 4 towers, has different functions, like offices, long stays, hotels, short stay hotel, gastronomy, residential, different kind of functions and with different heights. So this tower, the longest one, contains 95% of the office areas and so on. And the design has started in 2013. In 2015, UN Studio wins the competition. And in 2017, we get into the game. It has started the construct in 2019, and it is due to 2023. A significant date. It is at this stage at the moment. They're working day and night. You can see one of the tower is already visible. The podium part is almost done. And there was one old facade they wanted to keep. Well, they didn't keep it, they demolished it, but they made a replica of it. And to work on such big and complex project with many stakeholders and many different kind of disciplines is requiring really well-defined management. This project is drawn in 3 locations: Amsterdam, Frankfurt, and Düsseldorf. And all those offices has their sub-offices, actually. In Istanbul, we are working 5 of us, and we are delivering information to Frankfurt, and Frankfurt is to Amsterdam, or we are delivering to Amsterdam. Some facade is coming from Amsterdam. And there are 10 BIM coordinators, 42 architects. This is only HPP side, by the way. 35 external companies. I don't know how many people are working for them in total. And we have a company to check and investigate all the informations that we are delivering or getting, which is called Ignite. But the project is around 3 offices. Group partner is the contractor, UN Studio is the designer and controlling the design at the moment. HPP is a drawer, actually, draftsman. We are delivering all the rough construction drawings precisely, but there are also electricians, civil engineers, mechanical engineers, facade consultant, facade designer, and even some digital consultants for the file formattings and so on. So to bring all these disciplines together, as Professor Çapkın mentioned before, we have to come up with an agreement that every single item is well defined and understandable by everyone, even for the laboring on the site, or for facade consultant or facade drawers, or mechanical guys or architects. So the first idea was to divide the models into the parts. For example, T2 stands for Tower 2, second tower, this one. And this tower has 4 modeling file. RBK stands for construction, I mean the concrete, slabs, shear walls, columns, openings in the core. GAP stands for common area, like the common corridors. MAP stands for interior. FAST stands for facade. And we have all those for every part of the project, for the towers, for the podiums, and for the basements. And as we bring all these together, and sorry, there is one more flow model, which is for the areas, for the rooms. As we bring them all together, we are establishing a COM model, which is a layout file with all the informations are included. And by the way, this is only for architectural purpose. And we have Zen files, which contains the information coming from electricians or civil engineers, from mechanical guys, for pipelines and air ventilations and so on. So altogether, they are creating one single project. And every single tower and the podium has its own coordination models. I'll quickly skip on this. And as this is too much information and too much data, every single thing, every single document should be delivered in a well-defined way. A Word document, an Excel document, or PDF or Navisworks should be decided before the project, and it should be freezed. And for every single element, think of a wall should be well defined, because at the beginning of the project, we are just putting a wall and we don't know what is this wall material is going to be, what kind of openings will be on it, and how the material will be delivered to the construction site. We don't know it yet, we just put the wall, but we know the potential, what this wall can be and what kind of information will be put in that wall. Even those parameters will be empty, but the parameters should be there. And the name of the parameters should be well defined. What I'm saying is, for example, the wall might contain three parts, like the structure of the wall, substrate of the wall, and finish of the wall. But that information should be meaningful for electricians, for the MEP guys, mechanical guys, as they want to open an opening and place a air ventilation going through the wall. They should know those information and should know if this wall is openable or stretchable or not. By those documents, they do know. And at the end, at the beginning of the project, we are delivering, which is called bibliothèque, a BIM standard file where we are defining doors, windows, or any kind of walls, columns, stairs. Think this as a construction warehouse. If somebody needs a type of door, they're going there, picking that door and placing in the project. They are not like downloading any door from the internet or creating it by their own. It should be from there. And even the line types, even the revision clouds, the doors, here you can see the door has no information at all. It has no frames, mullions, and so on. But as the level of development goes deeper and deeper, those will be defined. So today, this is the content library. Like, there are so many different kind of doors we have now, because the project requirements has got versatile and differentiated. And here's an example of a door. And here you can see an orange box around the door, which is not part of the door. It is part of the door, but it is representing an information, which is for, later I will mention, the clash detection. What I mean, as the different disciplines creating different models, some discipline may want to pass through a pipeline here as they don't see the door as it opened. But this box preventing any overlapping from other disciplines. So in real life, we don't see it such a box, but in project coordination, we need to place this. And as we are well defining everything, we can create such a fancy, colorful layouts for different purposes. For example, let's say I want my fire protection 90 minutes doors to be presented as in green. And we put that in legend. And here we can see they are all green, or any different kind of coloring as you wish them. And we can list them, we can send to the other consultant as Excel, as PDF, and it's not always that we know every specific kind of specification of the doors. Sometimes it's the consultant filling up those information and we are getting it back. So there might be some empty slots. We are sending them, they are saying that this will be fireproof 90 minutes or 60 minutes, and then we getting those information back into the Revit with exchanging file. There is also, as I mentioned, project coordinators. They don't have to go into the model and draw or make drawings or create 3D objects. They have their own platform to review things. As the model is getting bigger and as the data is getting bigger, as mentioned before, it's really hard to work with low capacity computers. So this is more downgraded data. The coordinators are taking the models as they, for example, they may want to see on the facade model and RBK model, which is concrete. They can solve the detail and find out the problematics in relation between these two models. This is the clash detection, as I mentioned before. For example, you can see this is a floor finish, I think, is going through the steel beam. So this is not acceptable. So sometimes you can ignore those things. You can say that, okay, floor finish can overlap with other things because the labor is not going to cut the steel column to place some wooden stuff. You can skip them, or you can, if you want to create like well-defined drawings, you have to cut this floor finish. And as you run some clash detections, there are sometimes thousands of overlapping stuff, and there are the coordinators are letting everybody know about those problems, and they are creating, we call it BCF files. As they see a clashing point, they can create an issue and send it to the responsible people, electricity or mechanical or architectural. And one of the most important points in this project is the openings. Here you can see the openings on the concrete floor. Is the workflow is, firstly, we are creating the opening as a dummy opening, and we are sending it to statical civil engineers, and they are making their calculations. Okay, you can place it here, you can make it smaller or even bigger. And the initial is starting with MAP guys, because they need some wires, pipelines, ventilations should go through. And as we get the initial improvement for them, we are sending them to the MAP guys, and they are creating their own files for us to implement. And we are deleting all the dummy openings, and we are importing all their openings to be placed in exact locations. And in such a big buildings, of course, there are some interior spaces which are identical. For the hotels, almost, I don't know, 100% of the hotel rooms are resembling to each other. Some of them are having slight differences. Of course, even a small nudge it should be different layout, but we are cataloging every resembling room layout as 3D model. And as we are making a change here, we are rerunning the catalog, and every layout type which is identical with this one, maybe this one is on the 30th floor, another one is on the 31, and let's think that there are 15 more of this type. We don't have to change going one by one. We are using there are so many companies making these kind of external tools. We are working with Digital Esbauen. We are running this catalog, and all those rooms are changing. It will take time, but it's better than going one by one, and to making that way is also decreasing human mistakes. Yeah. And also I will talk a little bit about the facade as well. So as we are designing the things, we can free-formally design whatever we want to, but when it comes to construction, the differences on the facade elements increasing the cost. So the contractor is asking us to make them resemble to each other as much as possible. And this is, as you see, as the colors are getting same, the facade elements sizes are getting same actually. And at the end we can say, okay, we need 15 of this type, 13 of this type, 120 of this type, or there are some bargaining. Can you make this type more of this kind of type and so on, because they cannot solve the detail of this one because it's so small and so on. Such discussions are going on. Yeah, we are doing this with scripting. Of course, we are not layouting every single element on the facade and going through them one by one. And at the end, we are creating the detail of it as we get approval of the optimization. And yeah, I want to show that this is the pipeline system. That's what MAP guys are delivering to us. We are importing this to the architectural models and running the clash detection. Here, you can see some pipelines are going through the wall. If I would hide this, I would see an opening here. So this is that for this kind of big buildings, it's always good to look from outside, but those big kind of buildings are machines actually. They need to work properly. They need to supply good quality air, water, waste management, and so on. This is how they are done. It's not only the appearance of the building, but inside is crazy, I would say. And here you can see that we have delivered this detail. There's an opening on the slab and a pipe going through. And here you can see the implement of it. Well, there is a little bit of mistake here. It's not like perfect shape like this, but that will do, I think. Yeah, and one of the most important thing is the management of the construction, because we are still drawing the project, and they are on the other side, they are constructing it, and we should know our tasks, when to deliver. For example, when they are gonna pour the concrete of the 5th floor of RT2, and before that date, at least 3 weeks ago, we need to deliver all the information to them, would be double checked, discussed again, and it will do. So they are running behind us. We are trying to escape from them, but this is not possible in the old way. We should do it with well-defined, agreed contracts. Every single element should be defined that way. And this is the active issues, solved issues, pending issues you can see here. Yeah, that's it. That's all I'm gonna say. Thank you very much for listening, and thank you very much for having me. I think I made it on time. Too much. 2 minutes too much, sorry.
Can I ask a question?
Sure.
Last project you mentioned about it, you told us design is continuing, but construction started. It means you are working on fast track project. I think it's design and build or integrated delivery. Which method you are using?
It is actually integrated delivery, but I should say in our contract, we have to deliver only rough construction precision. We don't really care about the floor finishes that much or interior walls that much, because they might be discussed later on. But rough constructions requires all the MAP systems. We need to integrate with them as well.
Okay, my question on this kind of projects, especially fast track projects, you have to split up the design team or BIM team. What does it mean? You have main office team and you have construction team. Do you have construction team, architectural, which they are modeling on the construction site, BIM models?
That's how it works. We are delivering our informations to the site, which is approved by different kinds of disciplines. And from the site, they are sending us their own drawings. And we are matching, those are PDFs. Those are no longer like 3D digital images, PDFs. And I'm opening up my Revit file, double checking their PDF files with the dimensions on them. I'm double checking, and I am putting a check mark on every single dimension. So at the end, it is always, I don't know how, this is their decisions, down to, you can, I can make a mistake by the dimension and can say, okay, this is 2 millimeters, who cares about it? But it's down to human mistakes, I don't know. It is open. But the whole process is done in Revit as low possible human mistake is.
Okay, I understand you have design manual in this project. I think you and studio prepared it.
Yeah. Design is freezed. Yeah. Design is freezed, but the facade, even the contractor may want to use different kind of facade system, which is not 10 centimeters, but 11 centimeters front of the concrete slab. That we can say what 1 centimeter will do, but the building is expanding, from all the dimensions. So you need to recalculate all the facade, but the main principles are done and freezed by UN Studio. We cannot change those kind of curvy, fugas and their depth and their looking. But those small detail changes make recalculations again and again. If you are asking design-wise, but the otherwise is the main principles, the shape of the core is done, but as MAP wants go through the shear wall, we are talking with the civil engineers and they need to change their rebar, I mean, the concrete reinforcement inside and find a solution. Most of the thing we are doing at this stage is coordination.
Yeah.
And it's taking, I don't know, 5 times more than designing a building.
Okay, thank you for your answers. It was a nice presentation.
Thank you. I did check the chat. No.
Thank you. If you have questions, you can ask them in Q&A, from Q&A. We have a short video of VitrA. Maybe while students thinking their questions, we can show that video.
Mm-hmm.
Just a few seconds. Sinem Hanım. Yes.
The video was like good old days, huh?
Yes.
Actually, I can ask a question, Nilay to warm up the space. So my name is Bengisu. I'm a lecturer in Bahçeşehir Üniversitesi. I'm giving building information modeling lectures to 3rd and 4th grades. And thank you for the both presentations. It was so good and fruitful for my students too. And I want to ask some questions to Mr. Açıkel. Actually, I have 2 questions. How are you dealing with QA/QC issues in your office? Like, do you have a content library of families, and do you have a dictionary of, let's say, parameters, and how you compare the parameters, like how you make sure that they are correct in the model? And what is your QA/QC procedure in the office? This is my first question. And the second one, what is the division in the office? Like every architect knows BIM or Revit or whatever you use in the office, or you have a different BIM group of architects, or some of them only does some codings, or some of the architects are only modeling and the rest are making some coordination issues. What is the division in the office, division of work? Thanks.
Thank you. We have in the Düsseldorf office, which is the main office, we have a group of people which started for a F4 project, creating, referencing DIN Deutsche Institute of norms and implementing them our families. And they are providing every single element as we are requiring from them. But before that project, there were no such a thing actually. Every office was doing their own stuff, but it's getting better and better, and it's creating a culture actually. But Professor Çapkın showed us is not a documentation actually. It's a culture, and it will develop and go on and go on and go on. Is the most important thing is to create this information. We have a content library, and time to time it may jump from one project to another project. For example, we have a really well-defined door in one project, and it might be used in another project because we are always talking with different offices, and we know what they are doing. And even from Turkey, we are working to the other projects. We are 20 here, 5 of us working for Frankfurt 4, some of us working for project in Munich and Berlin. And every Friday we are making a meeting about those issues. And about the titles, we do not have titles. There is only one specific that group, like BIM group somewhere in Düsseldorf. But apart from that, of course, every single colleague has its own point of interest. For example, I'm really interested in parametric design. There's one guy, his knowledge about detail is, I don't know, he's a library, amazing. He's still drawing with his hand, and you know, but he is using Revit too. I am trying to draw with my hand, but I'm not that talented. Some colleagues are using render engines, and they can create really good renderings. Some of them are really good about graphic design, but we are not saying that this guy is doing that, this guy is doing it. They is always helping each other. Everybody is trying to develop themselves. It's like let's say a football team. Somebody is a defender or a striker, but it's a team. And even on our cards, we don't have titles. No BIM manager or senior or junior. Well, office directors are written as office directors. But apart from that, no. It's not like upward hierarchy. It's really, I don't know how to say, horizontal.
Mm-hmm. Okay, thank you.
I don't know if this is a true way to develop an office or not, but this is how it is.
Mm-hmm. Yeah, this is a European way of working, actually, which is good, I think. Everybody can contribute to the office, to the team, different ways. So I think this is so important. And it's so crucial for BIM, you know.
Yeah. Buğrahan is not here, but I find myself sometimes giving job to him, like, Buğrahan, you need to do this. This is kind of weird, but
yeah,
this is how it is.
And are you using some cloud systems while communicating?
Yeah, BIM 360, but we have our local server, which is connected to Düsseldorf. But for some projects, for example, for Frankfurt 4, it's on cloud. And me too. I don't know.
The whole project or some parts?
The whole project.
The whole project, yeah. Okay.
But there are some certain type of documents like DWG files or DGM. They are stored in local files as well. We are using Think project, and we are delivering them to the other principals via cloud.
Yeah, thank you. And I have another question to Mr. Çapkın. So what is your opinion on like Revit's 2D parts? Like how do you find Revit's sheet parts, like creating some 2D outputs? Is it enough for you to create these kinds of outputs, or is there a way to we don't have actually some AutoCAD exports. We cannot export a sheet as good as AutoCAD. What do you think about the 2D part of Revit?
Thank you for.
I think there are missing parts, I think.
Thank you for your nice question. I would like to show. Now, I think you are talking about the representation of the project. It's very easy, but there are different type of techniques which they use by the companies. I think Mr. Veysel's company is using. There are predefined standards for Revit and other BIM programs. First, I need to open the project. Wait a second, please. This is the nicest, one of the nicest way of the Revit. For example, when you are talking about the 2D drawings, we have too many techniques to represent our drawing. BIM can be in 3 different shapes. One of them text, the other one 2D, the last one is the 3D. Now we are talking about the 2D representation. There is a limitation in Revit. You cannot model something less than 0.7 millimeters. And never we are drawing something like that, because that's the production of the steel frames of the facade millions. No need to draw them. Generally, we are using a technique for that kind of stuff. We are creating a drafting view. Wait a second, please, because this has to go. This is not going. Perfect. One technique, you can use detailed models. To use detailed models, you have enough information to model it. Did you remember I show you one detailed family? I put 6 different levels inside of this family. This is a very basic one, but it's representing 6 different levels. This is the coarse level. This is the medium. This is the fine. When we look at the 3rd dimension, coarse, medium, Fine. This is the one of the easiest way, but you have to increase the knowledge. If you don't have enough knowledge, there is a problem. How you can increase? There are some technical documentations. Some of them from companies you can take. Some of them on the internet. There are some books which they are describing how to construct, how to build your information on BIM environment. They are describing. When you read them, you can reach this information. Other technique, we are not modeling, we are not drawing everything in Revit. What's the other technique? This is the other technique. For example, facade detail. I write down facade detail and click OK. Now I have facade detail. One technique, I can draw with line. This one is very important. I am not modeling. I am just drawing something. This is one technique. Another technique, you can put AutoCAD file inside of your Revit. How we can put, for example, Saray Aluminium. They gave you a custom detail. You can link it to here. No need to draw. We are not drawing everything in our BIM projects. The other technique is, it's very basic technique. You can take a piece of the model. After that, you can manipulate it. Let's have a look at, I am sorry. This is not a lecture, I know, but I just want to show. I take the detail. After that, when I double click, I can manipulate this place with third dimensional equipments, families, or two dimensional. It depends on my decision. Generally, we can do, and you ask, is it powerful or not? Revit, 2D, 3D, and text dimensions, they are very powerful. It depends on your approach and how you do it. The other one, exporting, you mentioned about. Standards very easy. One of the easiest thing is to export. When you click to this place, you can prepare your family. What's the family? For example, in your company or in your university, you have a layer standard. I think last year, Bayındırlık Bakanlığı released one layering standard for CAD. You can use that one. Just click here to load file. When you load it, all settings will change. All naming convention will change. You will just click to OK. For example, 10 person working on this project. You will just export. After that, all workers, all team members will see the same thing. This is one of the easiest technique in Revit. It's very useful. Another one, you can change the file formats very easily. For example, this is Power BI. We mentioned about 2 dimension, but there is another dimension, text dimension, tableaus. We can use Power BI, Power Business Intelligence, or Tableau program to create other things. For example, this is 2-dimensional drawing inside of my animation. Let's call it animation. It's very easy to make. Just you have to describe the processes very well. This is very important because somebody use a different type of technique. There will be huge problem for you. You cannot take the correct information from this 2-dimensional drawing or these texts. Is it enough or any other?
Yes, it's enough actually. But still, Revit's outputs are not like as good as AutoCAD outputs, because AutoCAD is for drafting exports, but Revit is for modeling, right? So
I am not agree with you. Why do you are thinking like that?
Because when we export it, like the line hierarchy, line thicknesses, drawing hierarchies are not as good as AutoCAD still, I think.
It's because you didn't arrange all settings. There are many settings inside of it.
We are using these kinds of templates. We are changing line types. We are creating lots of different line types, line weights, etc. And also we are using filters, but still it's not as good as AutoCAD. this is the biggest weakness, I think. We still need to use AutoCAD for covering some parts, some 2D drawings. We need AutoCAD's help sometimes.
Miss Bengisu, I am not agree with you because I never leave a problem like you faced. We should ask to Mr. Veysel, is there a problem like Miss Bengisu described, or you didn't face?
Choose your side.
I'm gonna say Revit is not promising on this. Why we are creating 2D files is we are creating 3-dimensional, super nice, well-defined models. Let's just send the model to the construction site, educate the laborers, and they will understand it without having 2D papers. Just provide.
Yes, exactly.
Tablets. You know?
Yeah, we shouldn't export any 2D drawings on paper, right? We need to take our tablets and go to the site directly. Yeah, totally agree.
That's how I could escape from the question. Sorry.
I want to show one thing. I am not writing anything at least 8 years. At least 8 years, I didn't write anything. I just use keynotes, many keynotes I am using, many things. For example, I will ask to this wall, what are you? And this wall will inform me. I have many catalogs, even Bayındırlık Bakanlığı, I prepare it, and you can prepare it, everyone can prepare it. It's very easy thing. I just want to show this one. This is one of the perfect specification of the Revit. I never write anything. Everything knows what they are and what's their code. And to make mistake, 100%. It's not 200. It's not 2. 1 in 100. And how you can make a mistake? You will select the wrong one. You will see it directly on the screen, and after that you will change it. This is the essence of the BIM. Mistakes will decrease. You cannot make mistake because everything automated and everything limited. And other possibility of the BIM process, Mr. Veysel described it very well. You can create your computational models very easily. Normally, when you want to draw something like that, it can take years. I am not joking. Really, it can take years. He just write down a mathematical formula, which we are calling as brain of the project, forms the brain of the BIM projects, and very complicated one they write down. I congratulate you. To understand and to make these kind of things, there are different levels. First, this is one of the up level. You have to have enough knowledge of the mathematics. Even sometimes I cannot do these kind of things. And your friend, Mr. Veysel, he is doing the best. We have a regulation. The first regulation, draw with hand. After that, write down the materials, parameters, other things. After, start your family. This is our process in our lectures, even in professional practice or university. Your friend doing the best, and I like your works. You are representing the new method of working very well. Thank you so much. I talk too much, I am sorry.
No.
In fact, we have another question on the chat box. I don't know, Bengisu Hocam, do you have further questions?
Yes. No, thank you for the answers. It was so nice. Thanks.
Okay. This question is from Suzan Girginkaya Akta from Suzan Hoca. First, she thanks to our speakers for their great presentations. She wonders the benefits of BIM use among AEC stakeholders during the COVID lockdown. Are there any reports on the increased efficiency of designers or on 5D planning during the lockdown? I don't know, maybe this addresses both of our speakers or whoever wants to.
I talk too much. I think Mr. Veysel should start.
This professor, you didn't talk enough, I think. Okay, I will start. Well, actually, as the as we are separated all around the world, I mean HPP, we were somehow ready for the lockdowns. Actually, we were already communicating with the other cities all around the world and other disciplines. But personally, for me, this is a personal answer. Working from home is like being in prison. It's not. I would report my performance went really low. Being in the office is the best, I think. But the technology was ready for every kind of requirements, and it's adapting itself. The Zoom was already there, but with the COVID, we started to use it. It was already there. But I don't know any reports. I'm really on the narrow down to 3D modeling. I think Professor Çapkın making wider research may know better than I do.
Estağfurullah, Mr. Veysel. You described very well. There are many perspectives. First perspective, I would like to put my educator glasses from education. When we look at it, there is a huge problem. The main problem, students like to touch. Students like to see you. This is the main problem, but we have many solutions. I am making many surveys. This is the, I think, third semester. Each semester I did many surveys. Even I have technical many documentations I can talk about. The main problem, psychological problems. One of them because of the disease. The other one, they are not seeing us. They cannot talk with us. They cannot communicate the way they used. This is the main problem. But there are nice stuff. One of them, they started to learn how they can work on the cloud system. New method of working they learned. And some of them get used to it and they stick it. They made very well projects. But many of them, for example, they quit the lectures. Some of them completely quit the university. I am really sorry about this one. I think it's nearly 5 or 7% of the students. They completely left the school on this period. In AEC sector, there was a huge problem. I have consultancy to some companies. When I'm working with them, they didn't know how to work. Because of this reason, we have to describe the collaborative working style, cloud system, one system, new method of working. When they get used to it, they fix the problem and they started to work. But there are additional problems. Their hardware is not enough to work these kind of things. They have to give some computers to their employers. Their software system, it wasn't ready. Same problems in the universities. For now, I don't know of any universities in Turkey. They are using one system. Do you know any universities? Okay.
We use multiple.
Sorry?
We also use multiple systems, not just one, in Bahçeşehir.
Are you using cloud systems in your projects? For example, design studio. Nobody coming to school, all of them drawing everything on the one common data environment.
No.
Okay, I am talking about this one. In the world, I can say even the name of the universities, less than 5 universities is doing this one. It depends on the what kind of possibilities you have. First one, this one. The second one, did university want it or not? Many universities, they don't want these kind of specifications. They are always saying same thing. We have security issues, we can't do it. I can say many things. If there's a specific question, I would like to answer it. I hope I could answer the question.
Yes, thank you very much. Also, thank you very much for the question. And yeah, Serge, one of our students, he totally agrees with you and says that we are missing the discussion that we used to do in the classes. And also there is another question from İlayda Aytin. She asks, how far will BIM systems go in the future? Is there a stopping point for this? And will we be able to catch up with the countries that are currently best advancing in this technology?
I can start. I'll have a short answer, I think. I don't know about the future. It will go on, it will develop further and further. Well, it is, you know, it is changing actually. The CAD system is also a part of this, and the hand drawing was also part of the CAD systems. We cannot say that, okay, that era has stopped, that one has started. You know, as we were drawing on the paper, we are defining 2 points and, you know, making a line like this. And in the AutoCAD, we are defining first point and the second point, and the line appears. And then now we are just defining 2 points and not giving the parameters, and the line appears. It will go on. I don't know. There are some stuff that you are just talking and telling the computer to create a bridge, and so I don't know where this will go. But we cannot escape from the technology and from the cyberspace. I think it is, we are spending more and more time on the cyberspace every day, more and more. And it will be hybrided more and more, I think. About to catch up with the countries, as the subject is we, I think meaning the Turkish citizens. In the Frankfurt 4 project, which is the biggest construction site and which is the biggest BIM project in Germany, that project is drawn at the moment with 20 colleagues, and 11 of them are graduated from Turkish universities. I'm Turkish citizens. I'm not that old, but the younger generation is really gorgeous. They are like sponges. They learning really fast. They don't intimidate to jump and dive into the work. And well, I don't know what is the reason behind that. I'm not an educator, but we are there. We are there. We can do. They are not way more better than us in that way. The problem is not about the architects. The problem is somewhere else. And I think that's enough.
Thank you very much. I'm checking the chat box. I think we don't have any more questions. Just I may have maybe last question or 2 questions somehow related with each other. I mean, with technological advancements, we assume that we will spare more time for ourselves, for our hobbies, and generally it's always the opposite. I mean, first one is that, what do you think about the, the practice of the profession in the future? I mean, what will be the effect of BIM on that, working practices? And the other one, I think this is the future of architecture. So our students should really improve themselves in that aspect. What do you suggest to them? Of course, they need to learn Revit, but you mentioned that, especially Professor Çapkın, it's not only about Revit. I mean, it's something broader than that. What will be your suggestions for our students?
Thank you so much, Ms. Nilay. When we look at the BIM, it started with the first human when they built up the first building. At that time, building was existing as an idea. By the time technology and processes developed, and today we have many developed skills, processes, technical standards, and the way of working. I would like to show you some stuff. In the future, first I would like to draw the picture. After that, I want to make them a little bit afraid, because I saw one documentary about what will happen. At that documentary, one hologram suddenly appeared on the screen, and there was a guy, he was eating something with his family. That hologram said to him, "You are fired. We find a new algorithm which is working better than you, and we are earning more money. Because of this reason, you are fired." His profession was architecture. He was architect. Now let's talk about what's happening on the sector and what we are doing in the Turkey. Now we are developing some technologies about construction, but when we look at the back, let's talk about last 50 years. Turkey is the one of the top constructor company in this world. But when we look at the sector, we didn't develop any technology about construction. We don't have anything about it. Today, what we have, now we have robotics in the construction site. Even in the Turkey, you can see one of them, Pharaoh's dog. Did you see it? Pharaoh dog. Mm-hmm. It was in the Autodesk University event. This one was walking between us. Do you know what it is doing? It is just walking inside of the building and scanning and creating three-dimensional model of the building. Cloud data, this one is calling us. The other one, today we have some very developed goggles. This is a concept, but this one is existing. What it is using for? Now, how we are working, how we are designing, how we are modeling, everything changed. Be careful, everything will not change. Everything changed even now. Everything changed. This is HoloLens. On the construction site, what they will construct. They are just looking to the site. There is, I think, one starting point. When you look there, you can directly see what's happening. Now, these pipes, they are missing. These pipes on the wrong place. How we are doing, how we will do architecture, it's completely changing from the roots. Because of this reason, we have to change the education system all around the world. We have to change the education system in the professional practice. This is the problematic of this age. We are not changing. Sometimes my colleagues or my teacher, my advisor asking to me, is AutoCAD better or not? This is not the problem. The problem is how we will represent our information. AutoCAD is a BIM tool, but it's not enough. Because of this reason, we are using other tools. BIM process will develop our skills, and we have to be ready about these robotics, the new way, the new methods of the working. That's all. Thank you so much. We can't hear you.
I would like to answer it from different point of perspective. You know, every physical object around us has properties as we understand them, as we are representing those properties, like the weight, the scale, I mean the volume of the things, or we have the language, we are relating it with the meaning, with the semantics. And as Professor Çapkın mentioned at the beginning of his presentation, he emphasized on the data. You know, what the data is the transferring of the information. In the early 19th century, there was this theory of information. And John Archibald said that if we can calculate information, we can transfer it. And he called it as bit. Is, you know, 1 bit, and 8 bit is 1 byte, and megabyte, kilobytes, and so on. And that's how we are transferring the information. And then he's coined that thing, that 8 from bit. He said everything will be represented as a information. Look around you, like a glass, tons of information. The working in such a project and being under the rain of the information, at some point I'm looking through not the beauty of the glass, but what is the stiffness, what is the rigidity of the, I'm trying to get the information from it. And everybody is trying to do this. We are talking not with the sound, as you Çapkın mentioned before, but with information transfer. To WhatsApp or Gmail or Slack or other kind of, even this meeting Zoom is translated by the information. Is this I'm not trying to draw a post-apocalyptic world. By the way, I love post-apocalyptic worlds, but where I'm standing is the definition of architect is changing. Do you remember when Oscar Niemeyer died? They said architect, the architect is dead. There is no more, there won't be any more architect. Well, they were discussing about there will be more disciplines into the architects. There is no one big guy deciding about everything. But I think, yeah, architect is not that, but it has changed the role. What I am looking into the architecture is like this. I have many information all around, and I am cherry picking some of them and creating my own relation between those two. And this is architecture for me. It's not the buildings, it's not the computer graphics, it's not the rendering, it's not the making the best BIM model. Well, is cherry picking those informations. The concrete, it can stand to the pressure, or the steel, it can stress to the upward directions. And you know, that's how architecture has come so far, creating the relations. And now it is down to information relations. That's what I am thinking about the future of it, actually. It doesn't matter if even if you are creating a home in the Minecraft, it is architecture. You are creating a relation between, it doesn't matter text information or integer information or 3D dimensional information. It doesn't matter it's in the real world or in the cyberspace.
Thank you very much. I think this discussion part also had been fascinating for our students to, you know, have some idea regarding the future of architecture and how profession will going to transform. Thank you for your answers. And I think it's almost 5:30. Neslihan Hanım and Ayşegül Hanım, we somehow exceeded the time, but the discussion was great. So thank you very much from my side. I would like to thank again to our speakers, Professor Çapkın and Veysel Açıkel, and also Bengisu Hocam, thank you very much for your contribution as a panelist. And once again, I would like to extend my thanks to Ayşegül Hanım and Neslihan Hanım. It had been really very informative for our students. I believe, thank you to Binat Yayıncılık, VitrA, and all, you know, contributors. So I leave the word to you here.
Thank you. We also would like to thank everyone. And also I would like to mention Bim Dictionary shortly after closing this program. With collaboration VitrA and BIM initiative, we published Bim Dictionary. Maybe you've seen these booklets before, but if you haven't seen them yet, it's our gift to all the participants of that event. We will going to send these booklets to your university. This project there is a Bim Dictionary project. It's an online dictionary. You can reach it now, and you may find many terms about BIM. It's an open source, but while we are thinking about making this BIM dictionary more popular with students, and especially in Turkey, we thinking making a printed copy of it, because somehow touching, as Furkan Hocam said before, students love touching. So we think if the students see the books and can learn some BIM terms via this published this publication, maybe it's also make the BIM more maybe more popular, and they can reach the information maybe easily. It was our aim, and also I would like to thank Furkan Çapkın. He is also one of the Turkish editors of this dictionary. So you can reach these booklets via also PDF, and also we have a special issue of Arredamento Mimarlık. It's also about BIM. It's theme about BIM. So if you wonder, if you want to read more text about this subject, you may reach that issue online. It can be reached via BOZ. Maybe we also add this. I can't remember the issue, which issue is what is, but we can write it. So that's all. Thank you. Oh,
Thank you. Thank you very much.
Thank you so much for your kind invitation, Binat and Bahçeşehir Üniversitesi. It was a pleasure to share knowledge and chat with you. Thank you for this event, inviting us.
Yeah, it was a pleasure. Thank you very much.
We thank you. Thank you.
As I added the link.
Yes, thank you.
You can check. I think now we can finish this webinar.
Okay, thank you so much.